In this section, we're studying ellipses, and an ellipse is just the set of points in a plane such that the sum of the distances from any point on the plane to two fixed points, we call them F1 and F2, is the constant sum D equals PF1 plus PF2, and we call F1 and F2 the foci. So this diagram sort of draws it out for you. If this is my ellipse right here, my point P is here, F1 or the foci 1 is there, and the focus 2 is there. What it's saying is that this distance plus this distance will give you the constant sum of the ellipse. So we're going to use the distance formula, and we could say, instead of twice, we could really say like a modified distance formula. But they want the constant sum for an ellipse with foci F1 0, -8, F2, 0, 8, and the point on the ellipse 0, 10. We're going to need to change this point to the point to be the point 6, 0, if you would change that on your notes. So here's a bit of a sketch, and you don't have to sketch this, but here's a bit of a sketch of what this would look like. Again, you don't have to sketch this particular problem. So I'm just sort of sketching where your foci would be. So your focus 1 would be at the point 0, -8. Notice it's not necessarily on the ellipse. And your focus 2 is 0, 8. And notice it's not necessarily on the ellipse. It's on the y-axis. And then the point 6, 0, that point would be on the x-axis. So we're finding this constant sum. So let's go ahead and do that. So D equals the square root of x1 minus x3 squared plus y1 minus y3 squared. So in order to plug in x1, x3, we need to know what x1 and x3 are. So we're going to label these points. We'll start with focus 1. This will be x1, y1. Focus 2 will be x2, y2. And then your point on the ellipse will always be x3, y3. So then just plugging in the values, we have x1 minus x3. Well, x1 is 0 minus x3 is 6. So 0 minus 6 squared plus y1 is -8 and y3 is 0. So -8 minus 0, and that's squared. So that's your first square root. Under your second square root, you'll have x2, so this time is 0 minus 6 squared, plus y2 is 8, 8 minus 0 squared. And we can simplify this a little bit. So your distance is the square root of 0 minus 6 is -6 squared plus -8 squared plus -6 squared plus 8 squared. So then we can simplify this sum. So this is going to be, your distance is the square root of -6 squared is 36. 8 squared is 64. And then you get the same thing in the next parentheses, so 36 plus 64. So your distance, 36 and 64 is 100, so this is square root of 100 plus the square root of 100. And the square root of 100 is just 10. So your distance is 10 plus 10, which in this case is 20. So your constant sum of the ellipse is 20. And that's all you would really need to do to find a constant sum. You don't need to draw the sketch, you just need to use the formula. So going to example 2 now, and here we're going to get some new terminology that we haven't really had before. So a circle has a radius. So any point from the center to the edge of a circle, we call that the radius. In this case, ellipses have something a little different. An ellipse has a set of two axes, or two axes. The longer axis of an ellipse is going to always be called the major axis, and it passes through both of the foci, or focus, whatever way you want to say it. The endpoints of the major axis are called the vertex, and the shorter axis of an ellipse is called the minor axis. And the endpoints of the minor axis are called the covertex of the ellipse. So the standard form of an ellipse is centered at 0, 0, and it depends on whether the major axis is horizontal or vertical. So is it longer on your x or is it longer on your y? So it's similar to a circle, except now you have it longer in one direction, either along the y-axis or along the x-axis. So we're going to fill in this chart together. So your major axis, whichever one is longer, in this case it's your x-axis is the major axis, and your y-axis is the smaller axis, so it's your minor axis. Your vertex are the points that are on your ellipse and they're on the major axis. So we're going to call this the vertex. And the vertex is going to get labeled as the point. In this case, it's going to be positive, positive A, comma 0. And then your other vertex on the other side is going to be negative A, comma 0. The points inside on your major axis, those are your focus. That's going to be the point negative C, comma 0. And then the other one is going to be the point C, comma 0. Then the last 2 points we have to label are these two, and these are going to be your covertices or your covertex. And that's going to be at the point 0, comma B and the point 0, comma negative B. So we labeled the horizontal one just so we could see what all this stuff was. The vertical one is given to you. The values of a, b, and c are related by the equation c squared equals a squared minus b squared. You want to use this form of the equation. This will tell you, this will help you find a specific value. So if you don't know what a is, you could use this equation to figure out what a was. So standard form, before we go on, the length of the major axis is 2a. Then the length of the minor axis is 2b, and a needs to be bigger than b. For us, we're going to only look at an ellipse with center 0, 0, but certainly an ellipse could have the center h, comma k as well. So something that's not 0, 0. Your major axis is either going to be horizontal or it's going to be vertical. So if it's horizontal, your equation is going to be x squared over a squared plus y squared over b squared equals 1. Your vertices are going to be negative a 0 and a comma 0. Your foci will be negative c comma 0 and c comma 0. I'm just getting these points from what we labeled above on the horizontal graph. And your covertex is 0 comma b and 0 negative b. Going now to your vertical, having your y-axis as your major axis, we're going to have y squared over a squared plus x squared over b squared equals 1. Your vertices are 0, negative a, and 0a. The foci are 0, negative c, and 0c. And the covertices are, and I wrote these ones in the wrong order, are 0, negative b, whoops, sorry, are negative b0 and b0. So really this one should say 0, negative b and 0, b. That's really what you should have. So those are sort of the basic definitions and terminology that you'll need to find the equation of ellipses. In the next video, I'll get into some of the examples from your notes.